For this inequality, the interval would be negative infinity to negative 3, union 2 to positive infinity. Great solving if you found those two regions. When we find the solution set for a quadratic inequality, we first want to start by finding the zeros. These are the x values that make the equation equal to 0. We factor this quadratic using x plus 3 times x minus 2 as the factors. Then we set each factor equal to 0 to get x equals negative 3 and x equals positive 2. We use these x values to set up our three intervals. So we know the values of x might be less than negative 3, between negative 3 and 2, or greater than 2. These different regions are the possible solutions to our inequality. We test a value in the first interval to see if it makes the inequality true. I'm going to choose the value x equals negative 4. Plugging in negative 4 for x, we'll get 6 is greater than 0, which we know is a true statement. This means any value less than negative 3 will make this inequality true. And notice we've already got our first interval, negative infinity to negative 3, here. We need to test a value now for interval 2. I'll use x equals 0 since that's pretty easy to plug in and evaluate. If x is equal to 0, then these two terms would drop out. They would just be 0, and we'd be left with negative 6 is greater than 0. We know this statement is not true, so this region is false. We exclude it from our solution set. And finally, we try a different value of x for our third interval. I'll use x equals 3. When we plug in x equals 3 here and here, we'll get the statement 6 is greater than 0. This is true. This means any value greater than 2 will satisfy our original inequality. And notice we have our second region, from 2 all the way up to positive infinity.